Thank you, Dr. Dinesh Kumar Likhi, for sharing your perspective. Later now, I would invite Dr. Pinakin Chaubal, Vice President and Group Chief Technology Officer, ArcelorMittal, to share his insight on the theme Innovation Pitch.
Thank you and namaskar. It's a pleasure to share a few thoughts with you. We have a limited amount of time. So just first an introduction to, quick introduction to ArcelorMittal. As Mr. Oman said, we are the largest steel producer in the world today with over 19 countries where we have footprint of crude steel production. We are also having a global mining portfolio, both in iron ore and coal, across various continents. These support both our own internal needs, partially, and also sometimes in the marketplace. Now, our philosophy in terms of innovation is very simple. We look at ourselves as a high-tech company, bringing the right technology at the right time to support the needs of our clients, but also very important, we believe that we are and we should play an important role in defining the steel industry of the future and the steel technology of the future. And in order to do that, we have a very wide range of research laboratories, largely in Europe and North and South America, and a very well-established network where we leverage universities, research institutes, and also, where appropriate, do co-developmental work with other steel companies under the appropriate protection laws. We also have, as you can see, presence where our major customers are, because it's one thing to do R&D, it's one thing to produce the right technologies, but it's also very important to bring the right kind of solutions to our customers. And this early involvement is an integral part of the way we bring value to our customers. Now, just to lay out and share a few thoughts, because we really do have a short amount of time, and we can't really go through and talk about all the potential technology developments across the entire value chain of the steel industry. I'd like to introduce to you the concept of sustainable manufacturing in the age of digitalization. And why did I put it in this way? Sustainable manufacturing is really what all our stakeholders are demanding of us. Whether it's our customers, whether it is our own workforce, or whether it's the community that we serve. All of them are looking at a few things which are very common. First of all, everyone wants to look at what we are doing internally. Our own internal processes, conservation of energy, conservation of resources, having a small footprint, safety. These are all demands for our internal processes. Protecting the environment, both inside and outside our four walls, is also very critical. And certainly our customers are looking, as some of the earlier speakers mentioned, and Mr. Dilip Uman also said, why not zero defect steel? But also very importantly, to sustainably bring the kind of solutions that they want. Because we don't want to be looked at as just a steel producer, but rather a solutions provider. Now, underlying all of this, and I think one of the speakers will talk about this a little bit today, is the whole world of digitalization. It's a tongue-twisting word, but there's a lot behind it. And we are convinced that digitalization and the technologies that are embedded in digitalization are and will be a key factor for the sustainability of the steel industry. So that's why we have coined this word, sustainable manufacturing in the age of digitalization. And what I'd like to do is just give you a brief glimpse of a few technologies that illustrate this point. Now, there's a lot of talk about protecting our environment. We've heard about recycling, reuse, remanufacture, etc., reduce. We've talked about emissions, dust emissions, chemical emissions, CO2. And I'd just like to focus in on CO2 because, as somebody mentioned, there is a major push today, in fact, if you've read at Davos forum that's going on, where all the participants are being asked to commit to certain key reductions in their own industrial sectors in terms of CO2. And the other emissions will come very fast, of course. Now, in terms of CO2, we have a major initiative in ArcelorMittal, and I'd like to just point out to you what the philosophy is here. There are three circles: circular carbon, clean power, and fossil fuels with carbon capture and storage. Circular carbon is a concept where we are talking of carbon being reused and recycled continuously. Yes, of course, by using agriculture and trees, that's one way. But here we are talking about taking carbon, converting it back into other chemicals. They are reused then back in our own processes, so maintain the circularity of carbon without necessarily putting it back in the ground. Clean power, all of you are fully aware of this. This is power from non-renewable resources, wind, water, and so on. And whether we like it or not, there is going to be a significant need for integrated steel making in the future. And use of fossil fuels will be important. So use of fossil fuels with carbon capture and storage is a critical lever that we all have to look at. So given these three key levers, we have a number of technologies that are either today in an industrial trial phase or will soon be in industrial trial phase, so that in the next decade, we expect to bring them online as full industrial processes. So I'll just walk through that in quick way. So on the right-hand side, you see learning to make biocoal. So this is from biomass, making carbon sources, which can be used in different ways within our own processes. Learning to inject rich gases in the blast furnace by using different techniques of catalytic reforming or non-catalytic reforming also. If clean power is available, we are also working on electrolysis, not molten salt electrolysis, but low temperature aqueous electrolysis for recovering iron directly from iron ores and sludges. We are in the process of setting up a facility to look at 100% hydrogen use for producing direct reduced iron. This is in Germany. Moving up, in the next arc there, we have two other projects that are going on right now: how to efficiently separate carbon monoxide and carbon dioxide, because this is a key part right now. And if you separate them, then each stream is rich in its particular chemical species and can be reused. So one of the projects that we are just starting up in our plant in Belgium is where we will convert CO containing gases along with some hydrogen to ethanol. And ethanol is a precursor for many things, including it could be mixed and as a biofuel also. So this shows you that we are today having major initiatives and major technology developments to address the challenge of CO2. Now, while we are doing things for our own processes, our customers are also looking at how we are manufacturing downstream. So what we have done is, last year we went into full production with a line in our plant in Belgium. The technology is called jet vapor deposition. So instead of hot dip galvanizing, we are coating sheet steel continuously by having a jet of zinc vapor. This technology allows us a couple of things. First of all, the deposition occurs at low temperature on the steel surface, and it also therefore allows us to completely dissociate the annealing cycle from the deposition cycle, therefore significantly improving the flexibility that we have for the steel chemistry and also for the properties that we need. Now, what is very interesting about this process is what is given below. So if you look at what's called the global warming indicator, and this is a pretty much standard way of looking at global warming potential of any particular technology, today's reference technology is hot dip galvanizing. Using that as 100%, this technology that we have developed and started up, which we call by trade name JetGal, has about a 65% global warming potential. So again, we are also looking at developing technologies and are developing technologies that are greener than what the competing technologies of today are. There was also a lot of talk about quality. So here, what we have done, first of all, on the left-hand side, you see the word digital twin of the coil. So in real time, we are able to determine either by measurement or by models, the mechanical properties and the surface characteristics of the steel that is being produced, no matter whether it's during cold rolling or it's during continuous annealing or galvanizing cycle. And of course, we are making a lot of efforts to ensure that as we are producing the steel, it is meeting the specification of the customer for which is being produced. And then online, prior to coiling, we are every meter putting barcodes which tell the customer what is the quality of that 1 meter of steel that is there. When this goes to the customer is able to read the barcode, and they can make appropriate changes in their processing line. The advantage is a win-win situation. We save by not having to scrap coils. The customer saves by not having to completely make mistakes in their stamping processes. And of course, in the future, we expect that every meter of coil that we send to the customer is going to be to the specification that he or she needs. There's a lot of talk about sorry, I'm looking at the wrong one. There's a lot of talk about automation. So what you see, sorry, something happened, 1 second. Okay, no, I'm sorry, it's okay. So a lot of talk about digitalization. So digitalization is really a combination of a bunch of technologies, all of which are becoming more and more commonplace because of a couple of things. First of all, the cost of sensors, the cost of data storage, the cost of computing has come down significantly. Today, our concept is that digitalization is really an end-to-end concept. We have to fully integrate, fully connect everything from our supply chain back or up, all the way up front to the customer. This connectivity is at the core of our digitalization initiatives, and also not just within one plant, but within several plants, as is appropriate. The digitalization process or the digitalization is not just a matter of putting in new technology. It is really a major transformation that has to occur in the way the workforce also deals with our own operations. Therefore, this is not just a simple CapEx project where you come in and put some new tools and walk away. It's a real major transformation in the whole way of how we look and make steel. On the next slide, couple of slides, I just have a little bit of example of that. So this is a picture of a crane that is handling a coil. So biggest problems in coil storage, of course, is the fact that you can damage the coil. So after you've spent all the money making the coil, you can damage it if you don't handle it properly, and you have to scrap it. It's also a dangerous area. So both from the point of view of safety and from the point of view of quality, we have started to automate our coil storage. Now, it's not just a matter of automation. There's a lot more. There are sensors that are put on the cranes, which allow it to read what the coil is. There are algorithms that allow the whole coil yard to be managed so that the crane movements are optimized and we can recover coils at the right time for the customers. There are sensors that are put on the cranes in order to make sure that the cranes are self-evaluating their own performance. And when there are issues, they are able to then alert that repairs are necessary. So that's what I mean by saying safe, intelligent, efficient handling. So it's not just a matter of automation. And finally, I just want to point out to you that there are technologies, and the previous speaker mentioned about it, and they are not in the laboratory or they're not space age anymore. We are already bringing it to our workplace. So on the left-hand side, you have 3D printing. You have a picture, for example, of a current part, which is a welding head. By using AI and generative technologies and algorithms, we modify the shape of that particular part, taking advantage of what 3D printing can do. So you will see at the very end what the modified part looks like. Significantly simpler, and by using 3D printing, we almost have no wastage. But the whole point here is that we already are, within our own company, having startups which are making these kind of spare parts and providing a value proposition for us. And on the right-hand side, I have another example. I'm not sure if you can see it very clearly, but the worker has two sets of equipment on him. On the top, it's a shoulder harness, so to speak, and in the bottom, it's more of a lower hip harness. These are exoskeletons. Maybe you've heard the word exoskeleton. We are already using exoskeletons in some of our plants, which allow, when the worker is doing heavy lifting, for example, the exoskeleton will aid the person in lifting. And therefore, the person does not have to expend as much energy and is much more a safer process. So these are the kinds of technologies I just wanted to share with you, showing what's coming into the steel industry and what's becoming commonplace. Thank you.